Hi, my name is Megan Gamenden, and today we're going to be talking about integer multiplication. So to begin, I'm going to define multiplication as combining many groups of the same size and then counting the total result. And so to begin, we'll use a problem as an example. So the problem that we're using is 2,379 times 1,204. And what this means is that we have 1,204 groups of 2,379 things. And to visualize this, I drew out, so this is one single group of 2,379 things. And I broke them down into their base 10 unit components, the thousands, hundreds, tens, and singles places. And since it would take me forever to draw out 1,204 groups of 2,074 things, I just put ... in the middle to represent all of the groups in between. And this represents 1,204 of these groups here. So to start, when we're looking at this problem, it makes it simpler to break down the 1,204 into its base 10 component as well, just as we did here in the thousands, 100s, tens, and singles. And so when we begin this multiplication process in the algorithm, we take 4 times 9. What does that mean? Well, we look at the 4 groups of 2,379 first. And what that means when we break 1,204 into its base 10 is we are looking at 4 single groups of 2,379 for our singles place value here. And then we're looking at, 0 of the tens place. So this is just to hold the place as there aren't actually any groups of 10, 0 here. Here's our hundreds place. We have 200 groups of 2,379, 200. And then we have 1,000, big chunk here, groups of 2,379, 1,000. So these are just chunked into their units. If I were to add them together, they would still equal 1,204. We just broke them up so we can work through a process like the algorithm. So 4 times 9, back to the groups of 4. So the 4 is our singles digit, as I stated before, and I broke it down here smaller away from the large problem here so that we could work through it as the first step. So 4 times 9 singles, singles place right here. 4 times 9 singles equals 36 singles. We can regroup that into 6 singles left over, carry over 3 rods, because 3 times 10 is 30 plus 6. And continue this process. So now we're going to multiply 4 times 7. The 7 represents 70, so I have 7 rods here. So 4 times 7 equals 28, plus the 3 rods from before, and that equals 31. So we leave 1 rod below, regroup to make 3 flats, carry that over. And so now we say 4 times 3, which equals 12, as I have written out here. 4 times 3, the 3 represents 300, as what flats represent 100, plus 3, which equals 15, 5 extra flats below, keep that in the flats column, carry the extra supercube over into the supercube or 1,000s column. And now we multiply again, we continue across 4 times 2,000, or the 2, which represents 2,000, 2 supercubes, which equals 8, plus the 1 which we carried over above, which equals 9. So up here you see that they're exactly the same. Our process matches. So now we've multiplied our 4 groups here. So now we're going to move across and multiply our tens unit by this entire number. But as there are only 0, there are none, all of the numbers across are going to be 0. However, before we do that, it's important to remember that in the algorithm you drop a 0. 1 0 in the first, and then 2 zeros in the second, and 3 in the third. We do that because instead of multiplying by the singles in the second row here, we are actually multiplying by the tens digit. And when we do that, what that means is when I move from the singles to the rods to the flat to the supercubes, I'm actually increasing by an exponent of 10, as the singles are 10 to the 0, rods are 10 to the first, flats are 10 to the second, 10 to the third for supercubes. And so to draw that out for you, I'll go up here again to the visual. So here's our singles here. So if I add up 10 groups of singles, that would actually form a rod. Here are my rods here. And so forth. Or add 10 rods together, that would actually form a flat. And so on. It keeps working its way up. So each time that I multiply by a greater digit, I need to drop a 0 because that means there are no singles left over. Because if I group up my 10 singles, they become a rod. There are no singles left. That's why I put the 0 in the singles column. So I follow that process each time that I move up. So singles, rods, flats, supercubes as I move across, which is why I increase a 0 each time to move over, and then I multiply across as I did with my 4. So to elaborate, second, I did my zeros. Anything times 0 equals 0, which explains all the zeros. I move over 2 because I'm moving into my flats. My 200, 2 represents 200. And so I multiply across again by the 9, the 7, the 3, and the 2 as before, because I'm looking at 200 groups of 2,379. Get these numbers here. And then I multiply again my final group of 1,000 times 200, 379, or 2,379, yep, because I'm looking at 1,000 groups. Get these numbers here. Don't forget about the 3 zeros. And then I add all these groups together, because remember we said 4 plus 0 plus 200 plus 1,000 to get the grand total number of groups. And so our final answer is 2,864,316